So previously we've done the vector cross product. If that's unfamiliar, jump back to that one there. But we've practiced calculating vector cross product, and we came across this identity that I've got down here, that if we had the length of our cross product between two vectors, it would be equal to the length of each vector multiplied together and times by the sine of the angle between them. So this angle here. So we now get to this space where, if we remember calculating the area of a triangle, it's half A times B sine C. Now, I've just used this notation here, and this is when we have a triangle. Let's just label this up, similar to our geometry, just so we're double checking. So A, B, and C are angles, and we end up with A, B, and C here. So what this means here is, it means that if I was going to calculate the area of the triangle between these two vectors, I could technically just go, well, sine C, and these two vectors will give me that area. Now, because of that, it also means that if I wanted to calculate the area of a vector, so let me just put this in here. So the area of a triangle between vectors, so if I was going to calculate the area between triangles of a vector, it would be, the area would be half the length of one of the vectors times the length of the other vector, and then times sine theta. And this is from our rule here, which is the area of a triangle when it's not right angle. So we've got that there. Now, hopefully we notice that this identity here is the cross product. So if we were going to calculate the area of a triangle, we can go half A cross B. And if we have the cross product, we can just, find the length of this vector and halve it, and we will have the area of that triangle. Now, the interesting thing here is, if we calculate the area of a triangle, then realistically, I'm just going to put that down here, if we were to double that, we would end up with so let's just double that out here. What's it going to be? Something like this will be our vector. You can see that this is a parallelogram. We end up with that, and it's just double the area. So if we double this formula up here, if we double this, the area of a parallelogram is just given by the cross product between the two vectors, and we take the length of that. So let's just use this to find the area of a triangle ABC given these points here. Now, if you wanted to, you could technically just use this area of the triangle. You just find the lengths of them, and you would find the angle between them. But that's harder for us to do algebraically. Whereas if we actually work out these vectors, we can actually come up with the triangle. So depending on the one you want to do, now the textbook has picked this A. I might pick A as well, but you can pick any of these points. The only reason I'm picking A is I'm going through the example for you, and I've got the textbook open, so I don't want to get this wrong at the same time. So I'll go A to B here, and then we've got C is over here. We're looking at this as the triangle A to B and A to C. Okay, and A to B is going to be equal to, I probably should just put this in. It's OB minus OA if you're remembering the formula, which means that we can just do here, OB is 2, 1, 4, and then we're going to have minus OA is -1, 2, and 3. Now, I'm just bringing this up because last time I went through intuitively how we'd do this. I'm hoping this makes it just a bit simpler. 2 plus 1, 1 minus 2, and then 4 minus 3. So this AB vector is 3, -1, and 1. And then our AC vector is going to be OC minus OA. So it will equal 0, 5, -1. minus -1, 2, and 3. This is going to be 0 take 1 is going to give me 0, 0 plus 1, and then I'm going to have 5 take 2, and then -1 take 3. This is, resulting vector is going to be 1, 3, and -4. So now we need to work out the cross product between these two, and we can then have the area. So we're going to have, let's just go, A cross product, A to C. Oh, that's a bit weird. I should have done B first. A to B, AB cross product with AC. And this is going to be equal to, we do our vector lines, I, J with a negative, K, and then our 3, -1, 1, 3, -1, 1, and then our other vector was 1, 3, and -4, 1, 3, -4. So this is going to give us, we're going to rush through this a little bit quicker than we have in the past. So -4 times, this is going to be, these multiplied together of +4, take 3. So I'm going to have 1 there for that value there. This next one, when you do the J, so let's do minus J, and this is going to be, obviously the J is taken out, so 3 times -4 is -12, take 1 times 1, so -13. And then our final one here is K, so K takes out these here. 3 times 3 is 9, take -1 times 1, it's going to be 10, so plus 10. We should be getting better at using our graphics calculator at this time. So now we've got the cross product. We've just got to work out the area equals half the length of this cross product. So AB cross AC, which is going to equal half the square root of 1 squared plus -13 squared plus 10 squared. All right, so this is going to be half square root. It's going to be 1 plus 169 plus 100, which means it equals half. 1 plus 169 is 170 plus 100, so half 270. You could take factors out of this to simplify it down, but they've written their answer as this. It's an area of a triangle is units squared. Now, if you're doing a parallelogram, you do it exactly the same way. You just have this 270. You wouldn't have this half in front. So they're both the same way. So have a good practice of those. Thanks.